So this video is the multiple choice questions for the AP Physics exam for the topic of optics, and it can also be used as practice for the IB and GCSE exams. So for the first question, what is the wavelength of an X-ray whose frequency is 1 × 10⁻18 Hz? So the speed of a wave is equal to its wavelength times its frequency. In vacuum or air, the speed of an X-ray or an electromagnetic wave in general is equal to c. So the wavelength is equal to c over f, equal to 3 × 10⁸ meter per second over 1 × 10⁻18 Hz. And this gives a wavelength of 3 × 10⁻10 meters. And so the answer is B. So for question 2, in Young's double-slit interference experiment, what is the difference in path length of the light waves from the two slits at the center of the first bright fringe, above the central maximum? So since the fringe is bright, the waves must interfere constructively. And this implies that the difference in path lengths must be a whole number times the wavelength. So this eliminates choices B, C, and E. The central maximum is equidistant from the two slits, so the difference in path is equal to 0. And at the first bright fringe above the central maximum, the difference in path is equal to 1 whole wavelength. So the answer is D. So for question 3, a beam of light in air is incident upon the smooth surface of a piece of flint glass as shown here. So if the reflected beam and the refracted beam are perpendicular to each other, what is the index of refraction of the glass? So as you can see, the reflected ray and the refracted ray are perpendicular to each other, and this is the angle, which is 90 degrees. So the angle of reflection is equal to the angle of incidence, and the angle of incidence is measured to the normal, which is 60 degrees. And so this is 60 degrees and this is 30. And because the refracted beam is perpendicular, this gives this angle to be equal to 60. And so the angle of refraction is equal to 30 because it is measured relative to the normal. So we want to find the index of refraction of the glass. So we apply Snell's law, which is n1 sine theta 1 is equal to n2 sine theta 2. The index of refraction of air is equal to 1, and the angle of incidence is equal to 60 degrees. And we want to find the index of refraction of the glass, n2, and the angle of refraction is equal to 30 degrees. So sine 60 is equal to square root of 3 over 2 equal to n2, and sine 30 is equal to half. And so n2 is equal to square root of 3. And so the answer is C. So for question 4, when green light of a wavelength of 500 nanometer in air travels through diamond of refractive index of 2.5, what is its wavelength? So we know that when a wave travels from one medium to the other, its speed and wavelength will change, but its frequency will remain constant. So it will have the same frequency in air as in diamond. So the wavelength in diamond of this light is equal to the speed of the light in diamond over the frequency. So the frequency is unchanged, but because the speed of light in diamond is less than that in air, then the wavelength of light in diamond is shorter than it is in air. So the speed in diamond is c over the refractive index of diamond. And this quantity here is the wavelength of the light in air. So it's equal to lambda air over nd, equal to 500 nanometers over 2.5. So the wavelength in diamond is equal to 200 nanometers. And the answer is A. So for question 5, a beam of light traveling in medium 1 strikes the interface to another transparent medium, medium 2. So if the speed of light is less in 2 than in 1, then the beam will, and we want to know if it will refract away or towards the normal. So because the speed of light in 2 is less than medium 1, then medium 2 will have a higher refractive index. And using Snell's law, this implies that theta 2 is less than theta 1, where theta 1 is the angle of incidence and theta 2 is the angle of refraction. So the beam would refract towards the normal upon transmission into medium 2. So the answer is A. So for question 6, if a clear liquid has a refractive index of 1.45 and a transparent solid has an index of 2.9, then for total internal reflection to occur at the interface between these two media, which of the following must be true? So the critical angle for total internal reflection is given by this equation. Sin theta c is equal to n2 over n1 equal to 1.45 over 2.9 equal to half. And this gives a critical angle equal to 30 degrees. And total internal reflection can happen only if the incident beam originates in the medium with a higher index of refraction and strikes the interface of the other medium at an angle of incidence greater than the critical angle. So the incident beam originates in the solid because it has a higher refractive index at an angle greater than 30. So the answer is A. So for question 7, an object is placed at 60 centimeters in front of a concave spherical mirror whose focal length is 40 centimeters. Which of the following best describes the image? So the object is placed at 60 centimeters and the focal length is 40 centimeters. And the equation used is 1 over p plus 1 over q is equal to 1 over f, where q is the distance of the image. So 1 over 60 centimeters plus 1 over q is equal to 1 over 40 centimeters. So 1 over q is equal to 1 over 120 centimeters. So q is equal to 120 centimeters. And so q is positive and the image is real. And so the answer is D. So for question 8, an object is placed 60 centimeters from a spherical convex mirror. If the mirror forms a virtual image 20 centimeters from the mirror, what's the magnitude of the mirror's radius of curvature? So because the image is virtual, we must write the image distance q as a negative quantity. So q is equal to minus 20 centimeters. The object is placed at 60 centimeters. So 1 over p plus 1 over q is equal to 1 over f. So 1 over 60 centimeters plus 1 over minus 20 centimeters is equal to 1 over f. And 1 over f is equal to 1 over minus 30 centimeters. So f is equal to minus 30 centimeters. So the focal length is half the radius of curvature. So r is equal to 2f equal to 2 times minus 30 centimeters equal to minus 60 centimeters. And its absolute value is equal to 60 centimeters. So the answer is D. So for question 9, the image created by a converging lens is projected onto a screen that's 60 centimeters from the lens. If the height of the image is 1/4 the height of the object, what's the focal length of the lens? So since the image is projected onto a screen, it must be real and therefore inverted. So the magnification must be negative. So m is equal to minus 1 over 4, which is equal to minus q over p. So p is equal to 4q. And because q is equal to 60 centimeters, because the image is projected on a screen at 60 centimeters from the lens, then p must be equal to 240 centimeters. And so 1 over p plus 1 over q is equal to 1 over f. So 1 over 240 centimeters plus 1 over 60 centimeters is equal to 1 over f. So 1 over f is equal to 1 over 48 centimeters, and so the focal length is equal to 48 centimeters. So the answer is C. So thank you for watching and see you in the next video.